One powerful feature in Q-Sys is the ability to utilize vector graphics to create visual elements that can allow operators and users to clearly understand what is going on in their system and just generally make your plugins look more visually appealing. Now, you may be wondering why we would use a vector graphic as opposed to, say, a raster image. The reason is twofold. First, vector graphics are natively resizable. Since they aren't based on pixels, we can make them as big or as small as we want without losing detail. Second, the scripting infrastructure in Q-Sys gives us the ability to dynamically create and modify the graphics, allowing us to create maps, charts, and even old-style DVD logo screensavers. As always, I'm going to start by copying my plugin template from my GitHub repository, saving it into the Q-Sys plugin folder on my computer. I'll enter the plugin info, and we can get working. There are two different methods that we can use to display a vector graphic. The first one utilizes the getControlLayout function. I'll start by adding an entry into the graphics table with the position and size for our graphic. Then add a type of SVG. The last thing we'll need in this entry is the vector graphic data, and this is a great time to talk about the format we need for the data. Due to the way that the Q-Sys Lua integration works, we need to encode all of our vector graphics as base64 in order for the system to be able to read it properly. In order to encode the data, we can either use a website or other external service if the image is static, or we can use the crypto library if the image is dynamic. Since the getControlLayout only allows for static images, we'll use a website to encode the data and paste the results into the image field. If we save this and bring the plugin into our design, we can see the result. Before we talk about the second method, I want to point your attention to the ever-helpful documentation. In the Q-Sys extensions to Lua, there's a section on Easy SVG. This section demonstrates on how to dynamically create a vector graphic with some pretty neat demos, and is a great way to learn more about what I'm going to show you now. The second way to insert an image is to apply it to a control. We'll start by adding a control, in this case an LED, but this works on buttons as well. Then we, of course, need to add an entry into the getControlLayout function. We're going to generate this graphic dynamically at the start of our program, and this will give us the framework needed to generate it based on the update of a control or based on a timer. However, we won't be demonstrating that today. I'll create a function here called updateGraphic, and inside of it, create an Easy SVG document with a size of 200 by 200. There isn't really much behind the decision on the size, and it has no relation to the size of the control as it's displayed, but you want to pay attention to the size you select as you place your elements. Next, I'll add a few elements here. This is not a tutorial on Easy SVG, so I won't go into much detail, and I'll just add in a few circles here. Now we have our graphic in a Lua object, but we need to get it to be readable by Q-Sys. Remember that we need to encode this data as base64, so the first thing we'll do is convert our document to a string using the toString function. This string is the final representation of our image, and it is exactly the same type of data as saved into any other SVG file. Next, we're going to encode our data as base64, then add it to a JSON structure with this Draw Chrome option. Now, this option is a little misleading. It tells Q-Sys whether or not we want to draw the default button elements underneath our graphic. If you want to, say, draw an icon on top of a button or indicator, you can set this to true or omit it as the default is true, but I'll set it to false here so we don't draw any of our button elements. Lastly, we assign this to our controls legend data, and we're done. Now, as a quick note, I normally do those last few steps all at once, like this, but I wanted to split the steps out to make it more clear what's going on. Either way works. All we have left to do at this point is to bring in a few objects. We will tell this script that it requires the RapidJSON and EasySVG libraries, since we utilize both of them. Then just call the updateGraphic function and save the file. Back in Q-Sys Designer, we can get our plugin, drag it in here, and open it up. On top, we see the graphic I added before in the getControlLayout function, and below it is a big red square LED. This is the initial state of our control. Since we're generating the graphic only during runtime, we see whatever state is set up based on the control layout. We could hide this image by setting the color of the control to transparent in the get control layout, but I'll leave it for now so I can show you if we emulate this design. It goes away, and we get our graphic. So that was a brief look at utilizing graphics for plugins in Q-Sys Designer. But before I go, I want to leave you with some bonus pieces of information. All the stuff I talked about with utilizing a control as our canvas, it also works in a text controller. That's actually how I created the crude DVD logo demo in the beginning of the video. Additionally, you can add a legend directly to a control in the get control layout function in case you want to add a static icon to a button or indicator. So I hope you enjoyed and that you learned something, and we'll see you all in the next part.